Find the volume. Find the volume of a region that is produced by rotating the region bounded by the curves. So the very first curve we have here is y equals x squared divided by 2. So bounded by this curve, x equals 0, x equals 2, and the x axis about the y axis. So this is your axis of rotation. So we want to find the volume of the region bounded by this whole curve. So there are lots of things going on here. So again, the very first thing you want to do is you want to start by drawing your x and your y axis. So let's start by drawing that out. So this is my x and this is my y axis. So let me label this as my y axis and this is my x axis. So the very first curve is you have y equals x squared divided by 2. So again, nothing fancy, just let's sketch the graph y equals x squared divided by 2. So this is my graph here for y equals x squared divided by 2. Now again, it says is also bounded by x equals 0. So this is point 0 here. This is the point 0. So x equals 0 is actually this line here, the line that we have here. Then x equals 2. Now this is let's assume this is the point 2 here, somewhere here. So x equals 2 is the line here, and then the whole thing just goes down and down and down like that. And the x-axis, so this is the x-axis, and then the whole thing goes like this. Now you observe that all the curves I've drawn, they actually bound a particular region. Now this is the region they bound. You can see, you'd observe this is where they bound. So this is the region they bound here. So in other words, the remaining parts of the curves, we don't need that. So this is the area which we need. Now what the question says is, it says that the region that is bounded by all these curves is rotated about the y-axis. So that is this region here is rotated about this y-axis. So there are lots of things going on. So the whole thing is rotating around this y-axis. So that tells me it's going to have an exact replica at the other part of the y-axis. In other words, the axis of rotation serves as a mirror. So it's going to have an image here. So let's say it has an image here. So again, this is meant to be a 3D diagram, but all we need is just the cross section, and then the whole idea will be brought out soonest. So if this is 2, then the other part is just going to be negative 2. So what the question says is, find the volume of a region that is produced by rotating this region here about the y-axis. So again, since the y-axis is our axis of rotation, so let's just denote that by dotted lines. So which we'll see. So now this is the main idea behind the whole thing. To do anything as regards this kind of integral problem, the very first thing is you slice. When you slice, you sum. Then the next thing is you integrate. So you could just take this as a very short abbreviation for SSI. You slice, you sum, and then you integrate. So in other words, what I meant here is to slice, I'm just going to pick a slice. When you pick a slice, now for this slice, they intersect. This is where they intersect the main region here. So in other words, when you begin to spin this whole thing around the y-axis, it's going to form a cylinder. You can see it's going to form a cylinder. So the only thing which we need to take into consideration is just the slice. Whatever we do with the slice, then the whole thing just comes out simply well. So now since the whole thing spins about the y-axis, what kind of shape is it going to give us? So let's just bring that. Let me bring this shape. Let me bring this here. Now if I extend this down here, so this is just going to be my slice. This is my slice here. It's going to have something like this. Let's say you have something like this. So this is my slice here that is being rotated here, and then you observe that there is an empty region here. Now the empty region which you have here and here, they are the hole. So there's just going to be a hole in this cylinder here. So now the thing is, how then do I find the radius, the outer radius and the inner radius? So what I mean is, for what you have here, how do I find the radius here? That is my r in. And then how do I find the outer radius? That's from here to here, the radius of the outer cylinder. Let's go back to the problem. Now if you go back to this problem here, what you'd observe is from here to here is the radius, it corresponds to the radius of the outer cylinder, and that's from 0 to 2. So that tells me my outer radius equals 2. Now the height of the cylinder is delta y. This is the change in y because it corresponds to the y-axis, so I'm going to call it change in y. Now how do I find the inner radius? Now to find the inner radius, we said the inner radius is just from here to here. That is, just think of it as the height of the function with respect to the y-axis. Now when you look at the function we have is, let's bring that here. You have y equals x squared divided by 2. But then all the things we are working with, we are working in terms of y. So since we are working, like you can see here, the height is in delta y, so we are working in terms of y. So I'm going to write the function here as a function of y instead of a function of x. So in other words, when you cross multiply, you have 2y equals x to the power 2, that is x squared equals 2y. Now to solve for x, so my x is just going to be the square root of 2y. So in other words, this function here could as well be written as x equals square root of 2y. So again, since this is the height of the function, so that tells me that the inner radius is just going to be, that is my r in equals the square root of 2y. So my r in, my inner radius is the square root of 2y, and my outer radius, that is r out, equals 2. So I want to find, so again you can see I'm working on the slice, so I want to find the volume of the slice. So to find the volume of the slice, that is which I'm going to call delta V, the volume of the slice is actually the volume of the outer cylinder minus the volume of the inner cylinder. So you want to find you want to find this. So I want to assume you understand what's happening here. So since the shape we have here is a cylinder, so the volume of the outer cylinder is just the formula for the volume of a cylinder, which is actually pi times so the radius of the outer cylinder is 2, that is 2 squared, then multiplied by the height. So we say the height is delta y minus the volume of the inner cylinder. This is pi. So again, what we're using is we're using the formula for the volume of a cylinder is pi r square times height. So this is pi r square times, this is my height. And then for the inner cylinder you have pi times the radius of the inner, which is the root of 2y all squared, then times delta y. So this is just going to give you pi, so you could bring this out, so you have 4, then minus the square root of 2y all squared, so this is just going to give you it's going to give you 2y, so this is negative 2y, and then you have delta y. So this is the volume of the cylinder. So the next thing says sum, so you want to sum, so that is my total volume. My total volume is just going to be the sum of everything I have here, that is pi times 4 negative 2y times delta y. And then to find the exact volume, which is the last step says integrate, and that's the last step. That's just going to be the integral, that is the limit as delta y tends to 0, the integral of pi times 4 negative 2y, then this changes to dy, and then this 2 has changed to the integral. So my y ranges from where to where? So let's go back to the problem. So the y ranges from, you can see, so the y ranges from 0 to this point here, and this point corresponds to what? Now if you look at this line here, let me look at this line here. The line you have here is 2. This is x equals 2, that's this line here, and the function itself is y equals x squared divided by 2. So when x is 2, when you plug in 2 here, you have x squared, that's going to be 4 divided by 2. So that tells me this line here is 2. So the limit of integration is from 0 to 2. So I come here, you have going from 0 to 2. So this is basically what you have here. And then this is just going to be, you have your pi. So the integral of 4, that is 4y, minus the integral of 2y, which is y squared. So this goes from 0 to 2, and then the whole thing just remains simplification. So whatever you have as your final answer is going to be your answer, and then this is going to be also in sorry, it should be in cubic units, because you're finding the volume. So that's basically what the question is. It's find the volume of the region, and that's what we obtained below.